Welcome to this session. As promised in the previous session, problem 2 had 5 parts. So we have solved part 1 and part 2 of question B. So in this case, we are going now to solve the third part when n is remember this was the question. Problem 2, find the exact value of this integral and use Simpson's third rule to approximate the above integral, taking 4, 6, 8, 10, and 12 intervals. So we had solved part 1 and 2 of this part B. So now let's solve for part 3 and part 4 when we have 8 and 10 intervals respectively. So B Roman 3, n equals to h. So h will be 1 minus 1 over 8, which is 2 over 8, which is 1 over 4. So you make a table of values. So remember the function is 1 over 1 plus x squared. So x and then f minus 1. When you add 1 over 4, you get minus 3 over 4. Add 1 over 4, you get minus a half. You add, you get minus a quarter. Add, you get 0. Next, 1 over 4. Next, a half. Next, 3 over 4. And next, 1. So when you put negative 1 into this function, you get a half. Put negative 3 over 4, you get 16 over 25. This will give you 4 over 5. This will give you 16 over 17. This is 1. 16 over 17. 4 over 5. 16 over 17. 16 over 25. And then a half. Now, once you have generated this table, then the next thing, let this one to be F0, and then F1, F2, F3, F4, F5, F6, F7, and then F8. So call this one F0, F1, F2, F3, F4, F5, F6, F7, F8. Now, we know by Simpson's rule, we have h over 3 x plus 4o plus 2e. X is the sum of the end ordinates. So we'll have h over 3 into F0 plus F8. And then for odd ones, we have F1, F3, F5, and then F7. Even ones, 2 into F2, F4, F6. We don't include F8 because it has already been included as one of the endpoints. So that's why we stop. So we'll have h in this case is 1 over 4. When you divide by 3, you get 1 over 12 into a half plus a half plus 4 into 16 over 25 plus 16 over 17 plus 16 over 17 plus 16 over 25 plus 2 into 4 over 5 plus 1 plus 4 over 5. When you work out this, you get I to be 1 over 12 into 1 plus 5376 over 425 plus 26 over 5. This will give you 1 over 12 times 8011 over 425. And then when you work out that one, you get 1.570784314. Error, let's call it E3, is the absolute value of the exact value, which is a half pi, minus this approximation. When you work out this one, you get 1.201306941 times 10 to the power minus 5, which is still less than the same number of steps we used for the case of trapezoidal rule. And then percentage error is given by this error over the exact value times 100%. When you work out, you get 7.6477575 13 times 10 to the power minus 4%. So this value is still less than the value we got with the same number of steps for the case of trapezoidal rule. Remember, when n was 8, the error was 5.2 times 10 to the power minus 3, while here we have 1.2 times 5 to the power minus 5. This is smaller than the other one. And then 7.6 times 10 to the power minus 4, and the other one was 3.3 times 10 to the power minus 1. So still this confirms that Simpson's third rule is a better approximation as compared to trapezoidal rule. Number 4, n equals to 10. So h will be 1 minus 1 minus 1 over 10, which is 2 over 10, which is 1 over 5. So you generate the table. So x and then f, negative 1, add 1 over 5, you get minus 4 over 5. And then we have minus 3 over 5. And then we have minus 2 over 5. And then we have minus 1 over 5. And then we have 0, 1 over 5, 2 over 5, 3 over 5, 4 over 5, 1. When remember that still the function is 1 over 1 plus x squared. So putting these values of x, we'll have a half, 25 over 41, 25 over 34, 25 over 29, 25 over 26, 1, 25 over 26, 25 over 29, 25 over 34, 25 over 41, and then a half. With this table with x and f values, call this one f0, f1, f2, f3, f4, f5, f6, f7, f8, f9, and f10. So by Simpson's third rule, the formula is h over 3 into x plus 4o plus 2e and ordinates f0 plus f10 plus 4 odd ones, f1, f3, f5, f7, and then f9. Even we'll have f2, F4, F6, F8. You don't add F10 because it has already been taken as the end ordinate. So then close. Now, in putting in the values, H is 1/5. When you divide by 3, you get 1/15. You have 1/15 into a half plus a half plus 4 into 25/41 plus 25/29 plus 1 plus 25/29 plus 25/41 plus twice into 25/34, 25/26 plus 25/26 plus 25/4. This would be 1/15 times this bracket. We have 1 plus 15.774605 plus 1500/221. This would be 1/15 times 23.561 930 82. That gives 1.570795388. And then error, let's call it E4, will be half pi minus this approximation that will give us 9.3901211 times 10 raised to minus 7. So which implies that percentage error in this computation is the same error we have gotten divided by the true value times 100%, which is 5.977936757 times 10 raised power minus 5%. So this is still less than the same number of chips we saw in the case of trapezoidal rule. So the remaining last bit, we'll do it in the next session when n is 12. Thank you.